Hi, welcome back. Hello, how are you? Hello. It's good to see you in face to face. It's good to have this recording going. I do enjoy making recordings of my class so that way you guys have it in case you just need a mental day and need to take a break or are absent or whatever. All right, so here we go. We've got two sections going on today. We're going to be doing section 7.1, ratios and proportions, and 7.2, similar polygons. Bless you. There are two assignments on the skill practice, the front 7.1 and the back 7.2. They will be counted as two different homework grades for you, the front and the back, so please make sure that you are completing both sides. All right, let's hop in and let's do the first section. Section 7.1, ratios and proportions. So let's talk about a ratio. Most of you are already familiar with what a ratio is, but maybe you forgot because it's been a hot minute. A ratio is any kind of comparison between two quantities, and it uses division. So it's basically just division. But you can express it in a word problem in three different ways. You can write it either as one of the numbers, the word two, and then the other number. You can write it as the first number, colon, and then the second number. Or you can just write it as a fraction because a fraction is division. In either case, the second quantity can never be zero. Because this is using division, the second number is what you're dividing by, and we can't divide by zero. So please, second number cannot be zero. Make sure that you express these things in simplest form. That means that these whole numbers are the smallest possible. Take a look at this aspect ratio 32 to 18 and 16 to 9. They're saying that these are equivalent. They're equivalent because if I were to take the 32 divided by 18 and divide out the common factors, that is 2 because they're both even, I'm going to get 16 over 9, which is exactly the same as this other ratio, 16 to 9. All right, the way you're going to see them is like in real world example number 1 in your notes. Example 1 in your notes is going to be exactly like the numbers from skill practice, and I'm going to abbreviate here off to the edge. Skill practice questions 1 through 5. So if you want to update your notes real quick or update your skill practice to tell you where to go and find an example of how to do this, let's talk through this little word problem. It's talking about sports, and it says that a baseball player's batting average is the ratio of. All right, let's look at what it's the ratio of. It's the ratio of the number of base hits to the number of at-bats. Now, it took me a little bit to realize what at-bat meant. At-bat meant the number of times I step up and I have the bat in my hand and I'm going to try to hit the ball. Not how many times I hit the ball, not how many times I miss the ball, but how many times I just try it. Okay, that's the number of at-bats. In this table here, this is the column for at-bats. These are the number of times this player has gone up to try to hit the ball for each and every year. And this other column is the number of times he actually hit the ball and managed to get somewhere for every year. The question is, what's his batting average? So the average over his entire career. That's this last one right here. So we're just going to make a fraction out of this. And since the number of base hits was listed first, that's in the numerator, the top of the fraction. And since the number of at-bats was listed second, that's in the bottom of the fraction, the denominator. All right, so we just grab our numbers, we put them in the correct spot, and then we simplify it as much as possible. In this particular example, they used a calculator to get the decimal, and for this one, that's totally okay. When you put the ratio where the denominator, the one on the bottom, is a 1, we give it a special name called the unit ratio. If you can throw it as a unit ratio, that would be awesome. If you don't remember to, just make sure it's in lowest terms, just like we did here with the aspect ratios for like this computer screen. Okay. Questions on how we do those? I'm going to take a look at the chat to see if there's questions, and don't forget, this will help you out with skills practice question 1 through 5 for section 7.1. Yeah, so in the chat, there was a comment there. So you just divide. Yes, that's all you need to do. All right. Now, where this ratio thing gets challenging is example number 2. And example number 2 is what you need to handle skills practice questions 12 through 15. So the bottom of your skill practice page. It's what's called extended ratios. It's when you have not 2 numbers, but 3 numbers. It seems whack and crazy, but basically it means this, that whatever piece that this thing is referring to, that these are all being multiplied by the same amount to generate the scaled up version of what we're looking for. And so you can extend this ratio that is 3 to 4 to 5 as 3x to 4x to 5x. And the reason this is helpful is now we can look at, say, something like triangles that have a real easy to remember angle sum and give you scaled up versions of these triangles. So this angle is 3 times x, this angle is 4 times x, and this angle is 5 times x. Well, instead of writing all that, we can just condense it to this extended ratio and say that the ratio of the measures of the angles in a triangle is 3 to 4 to 5. And it just makes the whole question take up a lot less space and a lot less ink. So what we do is we take that 3 to 4 to 5 and we rewrite it as 3x to 4x to 5x. And because we're dealing with the measures of the angles, we're going to go to angle sum and add them together. 3x plus 4x plus 5x. That's our angle sum of 180. Add up all of your like terms. 3x plus 4x plus 5x is 12x. Divide both sides by 12, and we get that x has a value of 15. This isn't the final answer though, because we were asked to find the measures of the angles. Remember that this angle was 3x. That means 3 times x, or in this case, 3 times 15. 3 times 15 is 45, and so this angle measures 45 degrees. If I do the same thing for all the other angles, I find that this angle measures 60 and this angle measures 75. And when I'm done, I can add these up and confirm that they do indeed reach 180 degrees. If you look at your skill practice questions 12 through 15, you're doing the exact same thing, but I believe for all of them, you're dealing with perimeter. So let's do this example guided practice number 2 together to help you have a reference for yourself for those questions 12 through 15. Guided practice says, in a triangle, the ratio of the measures of the sides is 2 to 2 to 3. That means that we have a side that measures 2x, we have another side that measures 2x, and we have another side that measures 3x. This is a triangle, so I only have 3 sides. And then it tells me the perimeter is 392 inches. Remember, perimeter means adding up all the sides. So I'm going to go ahead and write that. I'm going to add up all the sides. I'm going to add the side that was 2x to the side that was 2x to the final side that was 3x, and that's going to equal 392. And now I have an equation that should be fairly easy to solve. Going to add all my x's together. 2 plus 2 is 4, plus 3 more is 7. And then x is whatever I get when I take 392 and divide it by 7. Someone help me out with that calculation, because I don't know where my calculator is. It's like what? Yeah, 392 divided by 7. 56? Okay, cool. But that's not X. So we've, excuse me, that's X. But that not might be the full answer. We have to go back and we've got to find out what it is they're asking for. They're asking for, in this case, the length of the longest side. That is, which one of these had the biggest number? The 3 was the biggest, so I'm looking for 3x, which really is 3 times x. And when you do 3 times x, you should get 168. At least if we did this division properly. When you're looking at skill practice 12 through 15, please make sure that you read very carefully to see which of the sides you're being asked for. They may ask for the shortest, they may ask for the longest, they may ask for all of them. Any questions on this procedure? Glancing in chat. Yep. So I threw that X in there because we're trying to use this to kind of scale up the triangle to make it however big we need it to be. I know that the ratios are 2, 2, and 3, but I don't really know what the final size is. So I'm going to multiply each of those ratios by the same number so it all scales the same way. So 2 times some number which I've made X, 2 times some other number which I've named X again, and then 3 times that same number, which again was X. And so by adding those together gives me my perimeter. That's where those X's are coming from. You're very welcome. That was a great question. Thank you so much. All right. I'm going to take a quick look at that skill practice so that you can see we've already figured out how to do 1 through 5. We just talked about how to do 12 through 15. All that's left is to figure out this stuff in the middle, 6 through 11. It's going to be some algebra. You may not have enough space here, so please feel free to grab an extra sheet of paper and do that work there. Just make sure you label which work goes to which item. Let's figure out how we do those. And this is something I think most of you are already really comfortable with, but let's give you those exact definitions and those exact names. So when you have a fraction equal to another fraction, it's called a proportion. And in a proportion, the left top number and the bottom right number are called the extremes. And the bottom left number and the top right number are called the means. So it's just an easy way for it to identify which ones we're talking about. Now, the neat thing is, and the thing that you're probably already familiar with, is that if we are to multiply the extremes and we multiply the means, we'll end up with something called the cross product. And this is where that whole cross multiply and solve comes from. So whenever you see two fractions equal each other, so a fraction, an equal sign, and a fraction, you can cross multiply and solve. And that's what we're going to do here. And I'm going to do for you example 3C right here in this workspace. So I'm going to do 3C for you because there's an example that looks a lot like 3C in the second section that we've got going on today in one of your worksheets. So I want to give you some examples. All right, so I am going to get my extremes, and that's these. So I'm going to circle those in one color, and I'm going to multiply them together. 7 times z plus 4. And that's equal to whatever I get when I multiply the means together, which is this group and this group. I think some people might have been taught it as like a little butterfly or something, but the proper name for it is cross product, because you're multiplying product and you're going across the equal sign and making like an X. All right, I'm gonna do some distribution. While I'm working on solving this out and showing you how the steps I'm gonna take, if you've got any questions, please feel free to ask either out loud if you're in studio audience or in the chat if you're on Zoom. And if you're watching this playback on YouTube, you can leave your question in the comment section and someone will answer you as soon as they can. You're probably a little faster than me because you're writing with a pencil and I'm writing with a mouse. If that's the case, please double check to make sure that I don't make a mistake because I'm monitoring you guys here live. I'm monitoring my live chat on Zoom. So there's a lot going on for my brain and I may make a stupid mistake. Please let me know if I've made a dumb mistake. Never be mad if you tell me that I've made a little error. All right, and here it's easy to see that our next step is going to be to divide both sides by 2. And when you do that, you should get this answer here of 37/2. All right, I didn't see any questions come up with chat. I'm going to give you a few more seconds to see if you got questions on how I did this cross product to solve the proportions. And then we'll move on to the next section. These are pretty quick because I'm pulling on stuff that hopefully you guys at least were a little familiar with from algebra. All right, feeling okay? Thumbs up in the chat, feeling okay? I saw a lot of heads bubble up and down. I got a thumbs up in the crowd. Awesome. Let's go ahead and I'm going to list out here which questions this is covering for you. That's skill practice questions 6 through 11. And off I go into my second set of notes. So for section 7.2, we are going to be solving some problems with something called similar polygons, and we're going to be doing that by writing proportions. So basically, the exact same skill that we just saw, we're going to use in very specific contexts now when it comes to polygons. Remember that polygons are two-dimensional shapes. They've got straight edges. They're all enclosed, so there's no holes or gaps, and these sides don't cross over each other. Now, polygons are similar when they have the same shape, so they're both like squares or something, but they're not necessarily the same size. Like maybe one square is a little bitty tiny and the other one's like really big. The way we can tell if polygons are similar, and the way we can prove, again, back to that word because geometry is all about proving things. The way we can prove if polygons are similar is if the corresponding angles are congruent, but their corresponding sides are proportional. That means when I write corresponding sides as fractions, I'm going to get the same value for each of the fractions every single time I do it. These two polygons that I'm looking at in my examples both have 4 sides. So I'm going to need to check the ratio of the sides 4 different times. And I want all 4 of those fractions to be the exact same fraction. If at any point I get a fraction that's different, then these sides are not proportional and there's no way these polygons can be similar. By the same token, if I'm checking the corresponding angles and I find that even one of the angles has a slightly different measurement for the degree than its corresponding partner on the other polygon, then there again is no way for these polygons to be similar. Just like when we're writing the congruent statement, remember when we wrote triangle something was congruent to triangle something else? The order in which we wrote the letters, the names of each corners, they had to be in like this specific order. The same thing happens here with the polygons. So notice how we've colored A and W to be the same color. Those two are corresponding. Those two are both written first. B and X now are the same color. Those were written second, so those are corresponding, and so forth. The symbol that we're going to use for similar is this symbol right here, the little squiggle. It's that same squiggle that we put on top of the equal sign to turn equals into congruent. So basically, we're taking the equal sign away from congruent to get the symbol for similar. Some more vocabulary. That ratio between the lengths of those corresponding sides, those fractions you generate when you look at how the sides are compared to each other, that's called the scale factor. And the scale factor depends on the order in which you make your comparison. So, for example, in this diagram, I've got triangle ABC similar to triangle XYZ. Now, if I state the triangle ABC information first, that goes on the top of the ratio, on the top of the fraction. And then if I list XYZ second, it goes on the bottom. When I do that, in this case, here's what my scale factor looks like. But if I flip the order of my comparison, if I state the scale factor of XYZ first to ABC second, then notice the order that I'm writing them in the fraction is now reversed. So when you're calculating your scale factors, and we're going to do an example here in a moment of finding those scale factors, please make sure that you're writing them in the same order of comparison. I don't care what order you decide to put them in at first, but once you've made a choice, it has to stay the same all the way through. Okay. Let's do a quick example. We're going to do guided practice number 2. We're going to determine whether these triangles are similar. And if they are, we're going to write that similarity statement, and we're going to write the scale factor. It's asking you to explain your reasoning, so we'll talk about that as we go. All right, I'm looking at this triangle, and I already noticed I've got 2 angles congruent. I've got this angle N with one little arc, and this angle on my other triangle R that also has one little arc. So those 2 are congruent. We can say they're corresponding. I've got this angle at Q with 2 arcs and this angle on my other triangle S with 2 arcs. We can say those 2 are corresponding. Now, we had way back in chapter 4, I think it was, something called the third angles theorem that said whenever I had 2 angles in a triangle congruent to each other, that automatically meant that that third angle that I didn't know anything about, it was going to be congruent too. So here's my third angle, P and T. I don't have information about them, but since their partners on the triangle are congruent to each other, they're going to be congruent to each other. So I've already got all 3 pairs of angles congruent to each other. It's one of the things I needed to show similarity. Now I just have to show that the sides are in proportion. I'm going to do that by writing a bunch of fractions. I'm going to start off by looking at this big triangle, and I'm going to compare big triangle to small triangle. Okay, big triangle to small triangle. All right, let's look at N to P. So I'm going to look at the fraction that goes from N to P, and that needs to be in a ratio with its corresponding side. It was blue to yellow, so I'm going to grab the side that goes blue to yellow. That's side RT. Here it is. Substitute. NP was 15. RT gives me 12. And when I simplify this, you can either simplify it manually. I think that's 5/4. Or if you want to throw it as a decimal at me, just to make it a little easier to think through, because some of these ratios end up with decimals, that's okay too. As a decimal, this is 1.25. We're going to do the same thing for all of the pairs of sides in these triangles. If, when we do this, we find that those other fractions are also the same as this, they're either 5/4 or as a decimal, they're 1.25, then these triangles are similar. I believe when we do these calculations, we find out that they are, and so we can write that they're similar. Writing that they're similar The first triangle, we can write it in whatever order we want, but now the second triangle, we have to follow the same pattern. So N, which is blue, goes first. So I'm going to put R. P, which I colored in yellow, has to go second. So T is next. And that leaves S at the end. My reasoning would be all three pairs of angles are congruent and all three sides are in proportion. Let me have your question. No questions? All right, this guided practice example will help you with questions 1 and 2 on your skill practice in section 7-2. The last 4 questions on the skill practice is a pretty short one, is handled by this guided practice down here, 3A and 3B. So I'm going to do my work over here. My apologies if this seems a little blurry. Hopefully it's not too blurry for you on your screens, but it's super blurry on mine. I think I did something weird when I was typesetting it. I'm so sorry. It says find the value of each variable if, and then there's this weird set of squigglies. This reads triangle JLM is similar to triangle QST. And I wrote that translation into English right here for you. Triangle JLM is similar to triangle QST. All right, so now that I know which ones are similar, I'm going to go ahead and highlight which pieces are corresponding. So J and Q were listed first. Those two are corresponding corners. L and S were listed next. So those are the corresponding corners. And then the final one, M and T, will be my corresponding. And there they are. All right, now that I know which sides are corresponding, I know that the ratio of their sides will be proportional. That means the ratio that I write between corresponding sides will be equal. All right, I want, for the first question, to find the value of X. Here's X right here between L and M. So I know I'm going to use LM. I'm going to put that in a fraction. Now I need to find the side that corresponds with LM on the other triangle. LM goes from green to blue, so I'm going to grab the side on the other triangle that goes green to blue. In this case, it's ST. I'm going to set that equal to another fraction, and now I get to pick any other pairs of sides I want. I just want to pick the one that's going to be the most useful. Now, if I look at JL, that's not useful to me right now because JL has a variable in it, and that will set up a single equation with 2 unknowns. Right now, can't solve those. So I'm going to ignore this one for the moment, and I'm going to grab this other side, which is JM. Notice that along the tops of these fractions is information on the same triangle. And on the bottoms are going to be the information for the other triangle. That'll help you set it up to make sure that you're not mixing things up and maybe messing up your scale factor. All right, so JM was from yellow to blue. So on my other triangle, I'm going to go yellow to blue. That's QT. And now I get to substitute. Once I get this substitution set up, you're going to see that it looks almost exactly like, actually, it looks completely like the section we did on skill practice 7-1, question 6 through 11. See, doesn't that look exactly like 6 through 11 on section 7-1? So you would handle this exactly like you handled those. Any other questions on these? No questions, cool. So I'm going to mark that this guided practice will help you with skill practice, not 6 through 11. 3 through 6. The last thing to say, and I don't have anything on your skill practice, is perimeter. So if you get a perimeter problem, just remember that since your perimeter is side lengths, you can add them all together into a fraction, and that will also be equal to one of your scale factors. All right, if there are no more questions looking in the chat and looking around the room, I'm glad to see everyone is still awake. I didn't bore you. I'm so glad. Awesome. We'll go ahead and do that YouTube outro. Thank you very much for tuning in. Don't forget to hit the like and subscribe button. Hit like and subscribe, maybe the bell, so that way if you're out, you know when I've uploaded your lecture video. Thank you again very much, and we'll see you next time. Bye.